1S1. Any unit in District 2, Zone 2, having a chainsaw and some availability to help out one of our own, please?
Just clearing my 38. I'll be on a 1019 to HCS.
1021-4642, priority 3,
Code
please.
2 for a 1055, no contact, well-being check on one of
Code
our
2
own.
location. Could I have a unit 1025 with me for Code 2? Bring in some water.
Okay guys, I'm going to do another test to prove a point here. I am currently using, I'll take the camera and show you what I'm doing here. So you can see here that we are on the RIPEG 4, which is Providence. And my UHF radio, the link radio, I don't know if you can see that, but it is on the link input. Alright, so I'm basically going to transmit with both radios at this location, and I want you to hear or see what happens rather. Hey, I'm in a really iffy spot right now. This is almost a dead zone over here, but I wanted to show you something. Low band to Providence. Now remember, this link radio is going to the exact same location. Okay, the link radio is going to the same location. The antennas are on the same building at the same height. I just want to show you now. Low band, UHF, same location. This is going in on the link. Ready? 1, 2, 3, 4, 5, link input, Providence node. Nothing. 5, 4, 3, 2, 1, Providence node check. 5, 4, 3, 2, 1.
5, 4, 3, 2, 1. Providence, no check. 5, 4, 3, 2, 1.
Right there shows you the difference between UHF at the exact same location and low band at the exact same location. Keep in mind that the UHF system, which is the link system, which normally we would never talk into it, but I'm showing you as an example of the differences between propagation of low band and UHF. Low band's making the trip, no problem. Keep in mind that the antenna that we're going into over at the farm, which is technically in Cranston, is 0 dB gain. It has no dB gain. It's what they call unity. And this UHF system antenna over there is 3 dB, and I still can't make it. 1, 2, 3, 4, 5 link input. And on low band, S1, check 1, 2, 3, 4, 5, Providence node input.
S1, check 1, 2, 3, 4, 5, Providence node input.
Okay, now I'm just going to drive up here just a little bit, and I bet you UHF will stop working. Just happened to be in a total dead zone for the last half a mile. I'm thinking if I drive up here and I don't pause this video so you can actually see legitimately. Now I'm going to pick up the microphone for the UHF and see if I can get in now. Up, I got in. 1, 2, 3, 4, 5. 5, 4, 3, 2, 1. 1, 2, 3, 4, 5. See, I'm barely getting in. I'm picket fencing. But if I try it on low band, let's try it on low band. 1, check 1, 2, 3, 4, 5, Providence.
1, check 1, 2, 3, 4, 5, Providence.
See? Now let's try again UHF. 1, 2, 3, 4, 5. Now I'm getting in.
1, 2, 3, 4, 5.
You hear how terrible my signal was getting in, but did you hear how the audio is still kind of punchy? That's what doesn't typically happen on low band when the signal gets really, really weak, which is another reason why the Category 3 systems are built in a modular fashion. That's why we have multiple zones where we always get a good signal, as long as you plan out the zones properly. But that example right there shows you the propagation differences between low band VHF and, say, our UHF link. Now, whether it's a UHF link or a UHF repeater, either way, it shows you that in that circumstance, low band would have blown UHF away just in the propagation, whereas the UHF side of the system didn't hear it at all. But again, that was just a test. We don't typically use, or we don't have any mobile UHF radios in most vehicles. It's in my vehicle because I need to test this stuff. But I just wanted to show you a prime example of the differences of propagation between the two.